Hello and welcome. We're going to go over this problem at a distance today. So let's get started. So given two strings, word one and word two, return the minimum number of operations required to convert word one to word two. You have the following three operations permitted in a word: insert a character, delete a character, replace a character. So our example one is input word one is horse and word two is Ross. And so um, we want to transform the word horse into Ross by replacing H with R, and then we get Horse and Rose, and then remove R. Then we get Rose and Ross, and then remove E, and then we get Ross and Ross. So that takes three insertion, deletion, replacing character operations. So that's for that word. And then for example two, you have intention and the word execution. And then if we want to turn intention um, to enention, remove T, and then enention to enention, replace I with E, and then enention to extension, replace N with X, and extension with an execution, replace N with C, and execution to execution, or insert U. So that requires five um, of these operations. So we output five. So we just want to understand this problem. So we just go about having an input with two words, two strings, word one and word two. And the output is the edit distance. Between the two words. Okay, so the match for this problem is it's going to be a DP programming problem. So we're going to be using some DP arrays to be able to do this problem. So let's get started with the plan. So the plan is to initialize length of word one and word two, and initialize DP array. And then we have for I in range over length word one, and for J in range over length word two plus one. We have if I equals 0, then we want dpij equals to j, and then if j equals 0, then we want dpij equals I. And then the word 1 ij I minus 1 is equal to word 2 I j minus 1. So if it's less elements, only one dpij equals dp I minus 1 j minus 1. So else we want to consider dpij equals to 1 plus the minimum of dp I minus 1 j minus 1 dp I and j minus 1 and dp I minus 1 j. And then we want to return dp ij. Okay, so let's implement this plan. So we have m equals length word 1, and n equals length word 2, and then we have dp equals 0 for x in range n plus 1. For y in range n plus 1. And then for I in range n plus 1. And for j in range n plus 1. We have if I equals 0, dpi j equals I equals j. If j equals 0, dpi j equals I. And then if for 1, I minus 1 equals 2, j minus 1, dpi j equals dp I minus 1, j minus 1. Else we have dpi j equals 1 plus min dpi minus 1, j minus 1, dpi j minus 1, dpi minus 1 j. And then we want to return dpm and ij is okay, so we have a solution. So let's look at Python tutor code for a review. So we just go about incrementing the distance, the dp array, and then we go into setting the distance array, and we continue to set the distance array until our last outputs, and then we go about and we return distance array, which is 2 in this case for Warren card. And you just this is just requires a deletion of D and also changing C to W. So that's the review for this problem. So then let's go about evaluating this problem. So this requires an OM times N time complexity. Since we use 2 for loops here, ranging from n to n, where m and n are the length of word 1, length of word 2, and we also require OM times n space complexity since we use this dp array of size n plus 1 times n plus 1. So that's a wrap for the analysis of this problem. Thanks for listening.